Hi, my name is Eskil Bennetsen from Denmark. I will give a talk on a major challenge for global agriculture: to produce enough food and other goods while reducing the environmental impacts. My focus is on greenhouse gas emissions, which are contributing to climate change. During the past 40 years, our food consumption has more than doubled, and with a larger fraction of animal products, we are putting unprecedented pressure on agriculture. And in 2050, we will need 70% more food. Can agriculture feed this demand? The challenge is that agricultural production is degrading biodiversity, water resources, soils, and climate change. We must diminish negative effects to sustain our own population. Current ways of farming are exacerbating climate change. Agricultural production is accountable for about 1/3 of our greenhouse gas emissions, but has great potential for cutting back on emissions. Even so, the agricultural sector is so far only being discussed whether and how it could be included in climate policy negotiations. The Kaya-Porter identity is a novel framework for analyzing greenhouse gas emissions from agriculture. By deconstructing emissions into its relevant elements, as illustrated here, it enables us to analyze how each are contributing to the change in total emissions. Hence, each element reveals the performance of the agricultural production, and each is a control handle we can address and set specific targets for in a future climate policy. We do know that the production must increase in the future. So, which element should we address to halt emissions? This chart illustrates the principle on how we work. We use available data, and then through a lot of calculations, we reach the outputs for each element. It can be used on any discrete level. We started out on Danish national level and currently working on regional and global level. Total emissions have escalated the past 40 years. From the top you see emissions from land use change, then emissions from crop production, and then at the bottom emissions from livestock, including fodder production. Absolute emissions from all sources have increased, but let's analyze it just a bit. From crop production, we see that the total emissions have increased, but actually emissions from soils and land use change has decreased when looking per produced unit. It is very important to realize this difference between absolute emissions and emissions per produced unit. Higher absolute emissions have been driven by yield increase mainly, but also the larger cultivated area. Although energy use has contributed to higher emissions per product, the magnitude is relatively small compared to other emission sources. In the livestock sector, emissions per produced unit from enteric fermentation, from manure, and those associated with fodder production are halved. Energy-based emissions have increased up till the mid-90s, but since then, the livestock sector has gotten more energy efficient. From the last bar illustrated, we see that all elements are actually reducing the carbon footprint of livestock production. Only the higher yields, providing us with the meat we demand, are causing higher absolute emissions. This is a story of an agricultural sector that has, while more than doubling its production, been able to partially decouple emissions from the production, but not nearly enough. To be able to feed ourselves in the future, we need to push these trends even further. Some mitigation options will require investment, but options as improved nutrient and rice management may actually provide net economic gains to the farmer and society due to better resource use efficiency. Other major potentials, as grass and rangeland management, are almost cost neutral. The very different performance in world regions in terms of carbon footprint may urge us to learn about and from each other. The very intensive systems in Europe have the least emissions. Australia is a bit above world average, but for most developing countries, the carbon footprint is much higher. Although agricultural production in Europe is relatively climate friendly, we Europeans are very high consuming people. For example, a large proportion of the Brazilian agricultural goods are being consumed in Europe. So, who is responsible for the coupled emissions? We still have to increase production to feed ourselves, and to stop land encroachment, we can only enhance the yields. A recent study concludes that global production of wheat, maize and rice could increase by around 50% if yield gaps are closed. To feed ourselves while mitigating climate change, we need to invest in productive and climate-smart agriculture and food systems. Our strive towards improving productivity, to reduce greenhouse gas emissions, and to adapt to an already changing climate are compelled to go hand in hand. But agriculture alone cannot do the trick. We must improve the whole circle, from the soil and back to the soil, and we can all take responsibility in our own lives. We must ask ourselves and each other, what is the moral ethical of living a good life in the Anthropocene? Thank you.